And without further ado, ladies and gentlemen, let's welcome the Chairman of Research, Innovation and Technology, Architect Edric Chu, to deliver his opening remarks. You can also give a round of applause. Thank you.
Good morning, distinguished guests, fellow architects, engineers and contractors, suppliers and friends. It is my great pleasure as a convener today to welcome you all to today's event, the Art and Craft of Off-Form Concrete. Off-Form Concrete has been long held a special place in architecture. It is a raw beauty, it is a structural honesty, and its timeless aesthetic appeal continue to inspire us. Yet, as many as we know, achieving excellence of form concrete is everything but simple. It demands not only the right material and the method, but also the craftsmanship, precision, and experience. Today, we are here to explore both the art and the craft, to acknowledge the creativity, the design potential of the off-form concrete, while also confronting a very real technical challenge that comes with it. From formwork quality and concrete mix design to the casting technique, curing condition, color consistency, and the workmanship, every detail contributes to its success or to its failure. This conference is designed as a dialogue between an architect, engineer, contractor, and the supplier. Each has a vital role to play by sharing the knowledge, experience, and solutions. We can collectively raise the standard of the off-form concrete practice. So let us approach today's session with open and curiosity. Let us exchange ideas freely, question assumptions, learn from each other, and above all, let us reaffirm our shared commitment to build not just with concrete, but with purpose, integrity, and vision. With that, I officially welcome you all to the Art and Craft of Form Concrete Talks, and wish you all have an inspiring talk ahead. Thank you.
Thank you so much, Architect Edric Chu. And now to begin this morning's presentations, we are pleased to welcome our first speaker, Mr. HEW WAI HONG, presenting the topic GDP Campus Concrete Case Study. Can we please have you on stage? Thank you so much. Okay, yeah, it's all yours.
Okay, quite a lot of people here. Good morning, everyone. Thank you, Pam, for inviting me here today for this sharing session. I'm Hong from GDP Architects. Okay, so I'll start a bit with my biodata. So I graduated from the Bartlett UCL and registered as an architect in the UK with ARB on 2016. And after that, you know, I'll be able to join the GDP Architects when I came back to Malaysia in 2020 and got the good opportunity to work on the Apple Store TRX. At the same time, working on GDP Campus with the GDP team when I was there. Okay, so in GDP, what is interesting is that I'm leading the specification and material research team as well. Before returning, I was working in Foster & Partners, mainly focusing on multidisciplinary projects involving in design of urban planning and mainly involved in Apple stores, Dubai Mall, Piazza Liberty, and Via Corso. So a bit history about GDP. So what's going on is that GDP started in Pusat Bandar in 1992, where we have a very small office. The whole intention of this GDP campus project, you know, we moved to Plaza Office in Bukit Damansara in 2000. Okay, it gets bigger, and we have to take multiple office location in Damansara between the year 2000 to 2024. So what's going on is that, you know, we have a a lot of branches under us, architect, interior planners, and so on. So throughout the years, there is this plan to have a GDP campus where we put everyone under the same roof. So in 2024, we finally did it. We put the entire KL team, around 450 of us, in the same building. So the GDP campus, it's not just a location. We design it with the intention that we want to inspire creativity, foster collaboration, and support the vision of excellence. Okay, so the main thing of putting everyone together, putting all GDP employees, staff all together, is really to encourage collaboration and allow us to work between the floors and between different studios that we have. Okay. Some data of the GDP campus. Okay, construction started in 2020 and it got completed in 2024. The team on the project, we have GDP Architects, we have Pekha on the From Web team, we have YTL here as well, M.I.E.M, they are doing our concrete, as well as TANG, Al-Ambia, who is the contractor on board on the project. So they will be sharing more technical information and technical input in the project. So I'd like to talk a bit about the design intent of the project. When we started the project, because it's a project by GDP for GDP, we have that intention that we want to explore raw material, exploring how to push the boundaries for concrete, steel, timber, and glass. So in today's topic, I will talk about the concrete, which is the title of the presentation today. So regarding the concrete, what is good to note is that we have different grade. We use different concrete grade for horizontal members and vertical members. The horizontal members, which is the slab, okay, they are in grade 35 concrete, and the vertical members, they are in grade 50 concrete. So I think Pekha will, explain more about the concrete strength and all that of how concrete grade is important in here. The formwork. The formwork is what characterizes the concrete that we see. It is the formwork that gives the surface finish that characterize it, because the formwork, similar like a cake, is the mold. It then reveals what we'll see underneath it. Okay, so for this project, there is a lot of discussion about what type of formwork to use, and we have moved forward to proceed with the Perry formwork, mainly because of its modular system, its quality, the straightness of it, and the durability and the possibility to reuse. So for Perry formwork, mainly it can be reused for roughly up to 8 times. So what is interesting about the formwork is, we have to be very mindful of the panel sizes that they come in, 1220 times 2440, in which how we have curated the entire concrete envelope, okay, including the structure, to align with all these alignment. This is some process showing how the concrete is casted. So I think I'll go a bit more. So you could see some detailed drawing, from the contractor, showing how the formwork is being put together, held into place. There are supports. They are tied together by tie rods, okay, before the rebars is then being placed and the concrete is poured in, okay. Okay, so besides the formwork, what is interesting and a very important decision that we have made is the use of placa box. Okay, what is this placa box? I'll show you in a bit more. So this is the design elevations. If you see the elevations, there are no slab lines. You can only see the lines which is showing up between levels, which are the elevation lines, and they are formed by the paneling of the formwork. So in this project, what we tried to do is to get rid of the joint line that is created by the slab, the double joint line, in order to see a smooth transition or consistency between the paneling, the big paneling of the elevation. So how the plucker box works is that when we first casted the columns or the walls, we inserted the plucker box into the casting together. Okay, so it will come with section of the rebar being planted together in the concrete. This is how you can see it being attached onto a column. Okay, the perimeter column wall, which will then be molded with the formwork and then pour into it. So this is a image showing how the column have been finished, okay, with the concrete casted, and you could see what is embedded in there is the plucker box. So what we need to do here is to hack out the concrete around the plucker box to remove this polystyrene plucker box. Okay, this is the situation after it's been removed, and you could see there's a lot of coupler there, and the use of this coupler, okay, is to allow the rebars to be inserted so that the rebar which was previously planted within the column could be continuous, joined by this coupler into the slab. Okay. This is an image showing how the double line from the slab is not being shown on the elevational concrete wall. Okay, so another important thing that we have decided is relevant to the formwork arrangement. Like I mentioned just now, the formwork mainly comes in 1220, 2440, as well as we have the capsule here, which I will elaborate a bit more. What is important is the is the formwork alignment. Okay, yeah, it's a formwork alignment in order to allow the allow it to work properly with our facade. In interacting between the glass facade, the concrete envelope. You could see here that we have even decided on how we want to set out the formwork, which then imprint this lining joints onto the soffit of our exposed ceiling. Okay, so decisions were made in the car park level up to the office level. Some images here showing how the joint line is being shown here profoundly interacting with the facade line. Okay, that's a double volume space on level 4. Similar in the car park as well, interfacing with where we have the van block. So talking about the image here just now, the team, we have decided to proceed with a flat slab without any beams. The whole reason is to allow a free interaction and organization with the MEP services. Okay. So I think on the flat slab, Becca would give you more information about the pre-camber slab. She will possibly talk more about that. So this is an image showing how a flat slab was, incorporated in the design to allow the services to be arranged with the concrete. Columns. Columns is another challenge that we face in the project. Different from the beams. Different from the square columns or the casting of the wall and the slab. These round columns, we use metal formwork, okay? And there was a lot of discussion about sizes, yeah? Sizes and how many modules in order to to meet the most cost-effective method. Yeah. Okay. So like I mentioned just now, there are a couple of columns modules that have been designed into the project. On the ground floor, we have modules that have necking and without necking of different height, and mainly it's about different height. How we standardize this is to keep them to certain sizes, to keep them to certain sizes and allow the formwork to be reused, okay, on different level by adding props to the bottom and the top for the necking. Okay, we made a decision to ensure the 1220 height of the joint, okay, in order to allow it to repeat itself, being different from the envelope of the building. So you can see how the columns sits more individually as compared to the columns. Yeah, if you're in the space, you could read the joint line differently compared to the envelope. Okay, so after the column finish and all that, just want to show this image about the protection that have been put on to all the concrete which is on site. This is mainly about the protection towards the air, water, and damage that is, that might potentially happen on site. I'd like to talk more about the concrete aesthetics. At the beginning of the project, after the design team have all the paperwork done together with the contractor, we went on site, and in the basement, the first thing that we do is a concrete mock-up. We do a mock-up to set the benchmarking, to understand the quality and workmanship from the contractor, and we discuss about details in terms of how the panel joints should be, whether it is just a butt joint or it is a very deep review, as well as the setting out of the tie. The tie rods. Those are all important, and those are great conversation that we have with the contractor, because they have certain distance that needs to be from the edge of the panels. Okay, so from there, this is a good result that we have achieved before we move on onto the concrete construction of the project. This image shows the string there, which is showing the setting out of the tie rods, as well as the bottle there, which is an important factor for the concrete construction. This is the formwork oil, which is applied on the peri-formwork, as well as the metal formwork for the concrete column. With the application of this oil brush on, it allows the easy peeling off of the removing of the formwork. Oops. Yeah. Okay. So sometimes what happens is that when you remove the formwork, there are oil stain which created this yellow stain on the surface of the concrete wall. So the way to get rid of it, basically to clean it up, is really to have a brush, to just brush it off, clean it with water, and get rid of this oil stain. Similar to this, concrete dripping that is formed from the foam and the sponge, we call it, that is integrated during the casting of the concrete within the formwork. Yep. Another defect that quite major in the project was honeycomb. There was one column which there are significant honeycomb. Okay, you can see on the bottom part of the column, where we then took a decision to demolish it. And the demolition process is not simple as well, because you can't demolish the entire column easily. So what the team have done is to demolish the almost the lower part of it, and then to cut off the rebar, and you can throw away the top part of the concrete column, and the bottom bit that's left will be hacked away, and then a new column will have to come up. What these gentlemen are looking here is a cold joint. Cold joint that happened on the grade 50 concrete due to the timing of the pouring. So when the concrete are poured too late, cold joint will happen. So what is interesting here is you see this worker here holding a dryer. So there are some repair method that we have implemented in the project. Okay, some special technique from Al-Ambia. Yep, it's very interesting, but I think it's sort of a trade secret. What we do here is with this repair method, we are able to bring the concrete, okay, back to a more aesthetic and appealing scenario, similar to off-form concrete and fair face concrete. Yeah, so a colleague here giving a thumbs up. I'm not sure if you can see here in this image. What is also interesting is the setting out of the nails. That's also another huge discussion between the architect and the contractor in where and how and aligning all the nails in order to make sure that, you know, the alignment and how you feel when we are next to the concrete wall. Okay. Next interesting part is the tie rods. So all these holes that are formed from the tie rods of the formwork. Okay. This is just showing two different tie rods, shape formed by a straight tie rods and a round tie rods. Okay. What we did to study this during the mock-up session. Another major decision that we have made is relevant to the implementation of the surface sealant on the exterior concrete. What we want to achieve is a continuity of concrete between the interior and exterior. However, due to the requirement of our weather, from rain and water, there is an important layer, which is this water repellent layer, which is being applied on the surface of the exterior concrete. So what is interesting about this surface sealant is that it is sort of a transparent layer. However, when you apply it, it create a creamy looking aesthetic, which, you know, do not be too afraid of it, because over time, within the next 28 days, it will disappear and being absorbed into the concrete. So in the end, it will give a very transparent look, which is shown in our project. So like a lot of concrete construction in KL, what is important is the coordination, early coordination between the concrete and all the other elements of the project. The glass facade, besides the concrete, the glass facade forms a big part of the entire GDP campus. So there's an important need to create this coordination in terms of design and alignment, which I mentioned just now, as well as a lot of cast-in. Yeah, a lot of cast-in that we have to do in order to allow the facade to be supported and sitting properly on the perimeter. Next big thing that the capsule can show very greatly is the coordination with structure. So besides concrete structure, there is also a steel structure which is embedded within the capsule. Okay, the steel structure is only on the slab level because there are steel beams being incorporated within the concrete, as well as then gelling together with the concrete columns on the what we call the landscape level. Okay, and this structure is then supported by slim steel columns. You can see here on the first and second level. Okay. The trellis as well is another engineering and another integration between the concrete and the steel structure. The trellis form a shading device to the interior, as well as create an environment for the landscape level. Bit of design intent. On-site photo. So what we have here is this steel structure, which from this sketch you can see here that there are some cast-in bolt as well as post-drill bolt in order to react to the condition on site. Yeah, on the landscape level and also on the level 8, where this is the two locations supporting the steel trellis. Okay. So that's the end result, where you see from level 9 the trellis. Now that we talk a lot about how we want to encourage transition between our people, our staff, the steel staircase, which is within the level 6, 7, 8, which is our office level, is a very important circulation to allow people to move around and collaborate. Similar to other engineering of the project, this is another marvel where the bolts are post-drill onto it. Okay. Some site photos, working with Pekka and the team. Okay, so in a concrete construction, and especially in a high-rise, not too high for the GDP campus, one interesting part of the project is the lift. It's a lift that runs from all the levels, okay? And the contractor did a very good job in plumbing the setting up, okay, in order to get a straightness for the shaft, for the lift car, as well as the lift opening for the doors to be incorporated. So I think there's a lot of discussion on this, a lot of coordination, but in the end of the day, plumbing line was the one that created and allowed things to be set out accurately. Some image showing the formwork within the lift shaft. What we have used is integration of this stainless steel plate as well as some grouting in order to absorb the minor discrepancy in between the each levels. However, the doors, the lift doors, will still have to be set to be accurate for every single levels. This image here shows people standing around here looking at the ceiling, looking at the soffit. What is going on here is a mock-up. It's a mock-up where we put together, mock up the services in order to understand on things that we would be integrating within the concrete structure and things that would be exposed. Okay. Yeah. So here are the services. The ductings, some fire sprinklers, pipes, and some cables, mainly the fire services which are exposed. Lighting cables, you can see here, are being integrated within the concrete slab. Similar to socket boxes, electrical socket boxes being integrated together with the concrete construction. Next is the ID part. There are ID which are then being designed and integrated together with the entire concrete framework. Other IDs in the project? Yeah, so I think the way we look at the GDP campus is to create a balance between the use of concrete as well as all the other elements in the project. Okay, so to create, to review how the concrete could be a backdrop as well as supporting the whole design intent, working together with all the alignments for in the project. You can see here the landscape area. Level 4, which is the meetings area and public area. Talking about the entrance, this is another integration that we have worked together with the engineers, structure engineers, in order to cast in the structure members before the casting of the concrete. You can see here how the concrete, the steel support is being casted in, where these rectangle holes will be then filled up, okay, cover up to create a continuous look between the concrete and only the slim profile of the metal, like achieved in this image. Okay. All right. Thank you.
Thank you once again, Mr. HEW WAI HONG, who of course graduated previously, as mentioned, from Bartlett, USI, with a Master's in Architecture and became a registered architect with ARB in 2018. And of course, he joined GDP Architects in 2020 and is recently worked on the Apple Store and of course the wonderful GDP campus you just saw a moment ago. So let's give him another round of applause. Thank you for the insightful presentation. Up next, our second speaker is Engineer Ng Pek Ha with a presentation titled Fair Face Concrete Buildings in Malaysia. So a little bit of a bio before I formally invite our speaker on top. Together with Dr. Hussein Razi Jarabi, the founder of Web Structures, Pek Ha started the Web Structures Kuala Lumpur office in 2004 and built the Web Structures reputation in Malaysia until January 2020 when Web was acquired. She of course continues to continue her passion in design, and without further ado, I'd like to now of course invite Engineer Ng Pek Ha to please come on to stage to give her the presentation.
Okay, I think I'm too short for this. Okay, all right. Okay, thank you, Hong. I feel very happy looking at in the presentation just now because you have great pictures which I need to borrow from you later. Okay, all right. Anyway, I actually we didn't collaborate our talk between me and Hong and Mr. Lim of YTL, whom I've worked with all the years, and especially also Mr. Tang of Al-Ambia. I first met him on the Park 7 project. That was way back in 2005, right? So actually, the topic that I'm talking about is actually about using fair face concrete construction for very tall buildings because it brings it to another level of difficulty. But before I start, I will very quickly answer the questions that somehow Hong has asked me to answer before I start, before I forget. Okay, the first thing first is that regarding the concrete grade of grade 35 and grade 50 for the GDP campus, certain columns had to be grade 50 even though it's only a 7-story building. The reason being that GDP wanted to have the same size of column, the circular columns, the round columns. So certain ones were grade 50. The slab was grade 35, that's correct. The second thing is about flat slab. To be honest, I really don't want to talk anymore about flat slab because people call us the flat slab people and I hate it. Okay, there's more to us than just the flat slab. Okay, never mind all that, forget it. It's okay, we can talk about it another time. Okay, the other thing, but for us, to be honest, the concrete was not challenging at all, because we worked with, it was a very good cooperation and collaboration with the architect, GDP, fantastic. And with the concrete supplier, you know, I didn't even know that you were supplying concrete. I left it all to Al-Ambia, to Mr. Tang. And because he got all the great formwork, Perry formwork, and you know the special box out, there was no issue. So actually I was quite oblivious to the difficulties that you faced in the concrete. But for this structure, the thing that was most challenging for us was actually the capsule. If you remember the image of the capsule, the first thing is that it's a two-legged support. You know, it's a linear support just sitting on two legs, so it's like this, and it's certainly not stable in this direction. That's the first thing. The second thing is that the thin slab that you see at the level is actually a transfer slab, because it's transferring the extremely tiny little columns that support the top two floors of the capsule. In fact, the columns are so tiny, Mr. Tang, that they are smaller diameter than your temporary prop. Okay, so never mind about that. Okay, so the reason why we needed the steel inserts, the steel insert you see in the capsule floor, they're not really beams. It's because of punching shear. You see, sometimes you always want to ask, how can we achieve such thin flat slabs in concrete? Well, embedded inside the interface between the column and the slab, sometimes we really need a structural steel insert. It's hidden. I think the architects don't care about it because you don't see it, but it does make concreting a lot more difficult for the contractor, right, Mr. Tang? Okay, the second thing that was really very interesting for us is actually the trellis. Okay, I need to say this. Okay, I'm not boasting, I need to say this. It's a triangle shape on plan, but at the long span, right, the span is 22 meters. It goes across 22 meters like that, right? And guess what? It's only a steel plate that is 200 mm deep, 200 mm. So there's no engineers here, I suppose, except for Mr. Lim. The slenderness ratio is 100. It's crazy. The slenderness ratio is 100 when something is considered slender, when it is like 30 or 40. And the thickness of the steel plate is only 45 mm. In fact, it was so wobbly, and the steel plate comes down to the very tall columns you see going up, so wobbly that the steel fabricator, right, Mr. Tang, you recall, Pelanta Insan, right? They refused to bring it to your site because they said it's so wobbly they can't even load it onto the lorry to bring it to the site. So I was dragged by GDP all the way to, I forgot where, okay, to load these things onto the plate and to say that they are okay. So, okay, that's my memory of this project. Okay, I think I better start my talk. Okay, how do I do this? Press. Okay, is it here? Okay. Concrete was invented by the Romans around 300 BC. I need to count, so it's 2025 plus 300. That's like 2,400 years ago. And I think we all remember this. It still stands today. Julius Caesar built his things to last forever, and it's true. I think it's really true. Because the Pantheon is there today, and it's unreinforced concrete, but the constituents of concrete that the Romans used is lime, volcanic ash, water, and rock pieces. Today, we keep two of it. That's water and rock pieces. We will call it aggregate, okay? But lime plus the volcanic ash is today replaced by cement, okay? So this is a marvel, okay? You see, they even have like waffle slabs at the top. Fantastic builders. Okay, actually, after the era of Julius Caesar, the knowledge of concrete was actually lost for more than 400 years. That's why you see there was no great buildings until a huge revival in the year about 1840, 19th century, because an English gentleman, sorry I forgot his name, is Joseph something, okay, invented cement as we know it today, Portland cement, because the looks of it and the texture of it looks like Portland stone in the UK, right? Then after that, concrete, became popular, and I think it reached its heydays in the modernist era in the early 20th century with the works of Corbusier and all these people that you know of. I won't speak of them. I'm talking to a whole room full of architects. Oh my God, up there too. Okay. Then let's fast forward to today. Look at this. This is amazing. Santiago Calatrava, right? Concrete, right? Okay, just now Hong said something quite interesting. Okay, he said that it was something about cooking. What do you say, Hong, about cooking? I kind of forgot. A cake. He said cake, not cooking, right? Okay, later, making concrete is very much like baking. Not exactly cooking, but baking. What it means is that two bakers can never exactly come up with the same cake, and you need a huge degree of rigor. You really have to read 100 grams of sugar, 200 grams of butter, or whatever. And one of the best bakers today is Mr. Lim from Bilcon, okay? But we wait for his talk later. So today, the grades of concrete, okay, it started with this grade 20. This is way back in the 1970s, 1980s. We have grade up to 30 concrete or 25. Then now, today, we don't hardly use any of these 20 or 30 anymore. In fact, we don't. And we go for grade 35, 50, 70, 80, 90, 100, and capping off at 115. 115, okay, by the way, what are these numbers? This number is what engineers call the compressive cube strength of the concrete in megapascals, the compression that it can take. And for the grade 115, it was the intention for the 1 mile tall building in the world, the Jeddah Tower, previously known as Kingdom Tower, to be of grade 115 concrete. But, and this is very familiar to us, actually, Mr. Lim, they give up. They give up, and the building is being built with grade 85 concrete, because the local expertise and track record for building such a high-strength concrete was doubtful. Now, that's a lesson that I am having a very hard time learning, not in Peninsular Malaysia, but to be very honest with you, in East Malaysia. I'm struggling with the concrete there because the local track record and experience just isn't there. So it's just like baking, all right? You can write all the recipes that you write, but like to write, but if you don't have the right baker, it just doesn't work. It's very different from steel, in which what you see is what you get. Okay. And of course, today, to get the higher grade concrete, you can't just use water and cement. You obviously have super plasticizers, which allows engineers to reduce the ratio of water so that you can get the high strength. Okay? Right. Okay, let's move on. Okay, I've said about this. Okay. This is a very interesting building because it is the first and at the moment only building that is so tall, 50 stories, 40 stories, and bravely made without cladding, without plastering on the exterior, but from concrete. Okay, let me be more precise. Okay, these shear walls that go up are structural shear walls. This whole project has only 3 columns. 1 column in Tower A, the 50-story, 1 in Tower B, and 1 in Tower C. That's all. The whole building is supported by these shear walls that you see, which are also expressed architecturally, okay? The key thing is the thickness of the shear wall, all of them are standard, is 600 mm thick, okay? But the 600 mm thick comprises 65 mm and 65 mm precast concrete panel. And the in situ, it forms a permanent formwork. You put it up there, then you form a mold, use it as a mold. It's a permanent left-in-place formwork, and then you cast in the in situ concrete inside, okay? It sounds very easy, honestly. And by the way, Hong, the GDP campus, right, I read some social media by all kinds of people, and, unfortunately to the layman public, a lot of the comments are like, we went cheapo. You know, we didn't put an expensive stone finish. I think a lot of you architects have this problem with clients, right? Why have you made this cheapo material? Why are we not seeing marble, stone, whatever, right? Okay, we need to send out this message. It's not cheap to create it, because we'll show you why, okay? Okay, you see this? I think it's not allowed today to have men inside the rebar cage, okay? But this is 2005, okay? So in 2005, the first thing you see is that the precast panels, the 65 mm thick precast panel with the end caps are there. And these precast panels, they are about 1.5 meter by 3.2 meters, okay? So it sounds very easy. You just make lots of them off-site, you bring them here and you just put them up. But you can't just put them up. It's very hard to make them level and aligned, especially at such high heights. You can't lift any of this. If any of you try pulling up the precast cover of the drain, we can't even lift it, right? So how do you lift it up? You lift it up with those orange things. That means the contractor, IJM, had to build what they call strong back, made of that orange steel frame, to just like you lift glass, you know? Then you tie them to this, and then the crane lifts them up, and the allowable tolerance, I forgot to mention, the architect we worked with was GDP together with Fosters and Partners. And the tolerance from one end of the wall to another, guess how much it was? 3 millimeters. Mr. Contractor, you almost die. 3 millimeters, okay? So anyway, that's what it is. And what are these men in the cage doing, okay? All right, the in-situ concrete is just normal. It's the rebars you see going up. But why do we need men in the cage, okay? The reason is this. Foster and GDP were very worried that the panels would drop off. You know, if you just have plain panels like that, then they just bond via some cement bonding to the in-situ. It will just drop off. It might drop off, you know, and that'd be serious, right? It'll kill someone below. So what happens is that we have little hair-like bars sticking out from the inner surface of these panels, which were, when they lifted, they were folded in, but you need to pull them straight. And this man is doing that. They're going around all the panels at the back and pulling out the bars. I'll show you. I think the next picture, okay, shows this. But okay, of course, it's a beautiful construction, a beautiful design on all aspects. Structure also, I have to say, okay? Because the flat slab can span 12 over meters, 250 mm thick, and I'll show you some, and it allows the architect to push the slab in and out, in and out, in and out, to articulate it by the slab edge, you know, instead of being framed by beams or whatever, also, I just want to tell you something interesting. This is the drop-off canopy in Troika. I think most of you have been there. Now, usually, the canopy is supported by the main building, right? This building is weird. The building is supported by the canopy, so I really hope somebody doesn't knock off the canopy. I need to tell one of the residents that, Joanne, who is actually sitting there, please don't knock off the canopy, okay? Okay, now these are the panels I'm trying to tell you about, 65 mm thick, marked with that. The mark of the pink dot is so that it's the right panel. You see, it's very confusing. It's like a jigsaw puzzle. So we always get the wrong pieces, so we have to mark, oh, which one is correct, oh, which one is wrong. Doesn't go here and there. And you can see the little metal at the bars at the back, yeah? Okay, so you see, okay, this is the jumping formwork going up, right? It is a jumping formwork. Just now, Hong talked about the couplers and all that. I'll show you the problem with the coupler in this building, okay? Okay, this is a zoom in. Can you see? The men in the wall were pulling, making it straight. You fold it in just like that bar there, and when you're in the wall, you have to pull it straight so that it can anchor into the in-situ concrete in the middle, okay? Yeah, that's it. Some of them being pulled straight. Okay. Okay. This is what I tell you. It's not so simple. There are so many types of panels. Do you see at the end there where the slab meets the wall? Now, Hong talked about the interface just now between, what's that called? What box up was that? What? Sorry? Plucker box. Okay, the plucker box. And we can't have the plucker box. So over here, this piece of panel is different. We have to build the precast panel in the exact shape and exact dimension so that the in-situ slab can enter into this thing. Not easy at all, okay? And, okay, Sorry, have to show off some structure. Even though some of the slabs span 12 meters flying across from wall to wall, the connectivity with the wall sometimes is only 600 by 600. Good one, right? Good one, right? Yeah. So flat slab lah, okay? Okay, yeah. Okay, one word about flat slab. Since the 31st of December 2021, okay, Malaysia is governed by the seismic code. There is a requirement to design for 7% ground peak acceleration, and flat slabs don't perform well in seismic conditions because of a lot of vibration and twisting and torsion, right? Now, it doesn't mean you can't do it, because Bangkok has a lot of flat slabs, high rises. You still can, but you need another competence level in terms of structural engineering, or for the Malaysian engineers anyway, okay? Not promoting ourselves, but come to us, we know how to do it, okay? Okay, okay, so, okay, there's the block. You see, you have to cut out all these panels, you almost die getting the right pieces. Okay, and this part for the contractor, Mr. Tang, is difficult because you know why? They suddenly cantilever one floor. Our prop cannot go up. So IGEM had to put those red color steel beam just to, you know, cast up those floors, right? This one you must see. Nobody notices it. I'm very sad. Look at the slab. The slab is supposed to sit on the column or whatever, that wall. Does it really sit? It doesn't, you know. Look at that. The corner there just touches. It's not on top. Okay? Okay, I'd like all of you architects to ask whoever the engineer is you're working with. Go and do this. It was tough. I won't tell you the secret, okay? Okay. Okay. Okay, coupler. This is a nightmare. Okay, why is it a nightmare? It's because, you see, the walls are all, they're not like aligned. They don't go in an XY grid. So the walls are all eccentric, you know, in terms of the orientation and plan. Because the architect wanted view, like they look like, they are like port views, okay, or viewport, sorry. Now, so these bars, you see, when you cast these columns, they use the jumping formwork. They go up. The walls go up 3 or 4 floors. Then the slab follows 3 or 4 floors behind. So they leave in this coupler. Coupler means it's like, how do I explain a coupler? How do I explain that? It's like a bottle cap with screw thread inside. And you cast it inside the vertical element so that later the bar can come, which is threaded, and then you screw inside. But you know what's the problem? The bars that you want to screw in are not perpendicular to the bottle cap that is inside, because the bars are skewed because of the floor. Oh my God, we had such a headache with this, and IGEM was fighting with everyone about this. So I won't tell you the secret again, but I'll give you a hint. You can use recycled wine bottle, corks of the wine bottle, to stuff up that little triangle space so that it doesn't get stuck with concrete. Okay, I'm not making any sense, okay, but okay, we can talk about that later, okay, if you like. Okay, very difficult, okay. All right, this one I show you is the easy one, you see? The coupler, and this is orthogonal, easy. Oh, okay, fast forward. End of my triangle slides. That was construction in the year 2005. We started. I think we ended like 2009. Now it's 2025, right? But actually this problem happened not in 2025, but it happened about, definitely before COVID, in about 2017. 2017 minus 5 is about 12 years. 12 years later, the building management show us picture like this. And to be honest, it's not a structural problem. It's not actually a structural problem. But unfortunately, architects like to think that anything to do with concrete is a structural engineer's problem. Very pissed about that. Okay? All right, we'll talk about that later too. Okay, they show us pictures like this. Now, you see this picture, and even worse, JUANG is your pictures actually, okay? Okay, all right. So what did the building management do? Not under our advice, on their own, they did this, okay? They hack out that, this is another part, but they hack it all out until they exposed the rebar that was inside the precast panel. This is the rebar inside the precast panels, the 65 mm thick precast panel, and they hope to repair this. But after they've done this, They said, shit, I don't know how to repair it. It's impossible. How can you make it look the same? The beauty and the, the uniformity of the surface. That's where we are today. Okay? JUANG is here, resident, representing building management, asking me, the structural engineer, about what should be an architectural problem. But never mind, okay? We love to extend our scope, okay? Okay, I'll tell you the problem, okay? Very simple. Okay, let's talk about, I think, you see, I don't know all these details because it was spec'd by the architect, okay? Okay, first and foremost, these panels are just concrete panels and they're so beautiful that no need to do anything to them, right? There was, in my memory, there was a concrete ceiling coat, water-based concrete ceiling coat. I think the one Hong you showed just now is a hydrophobic that repel the water one. This one, I don't know. I can't remember it's, all these things. I think nobody told us anyway what they use, but I know it's concrete based. I guess it's also hydrophobic. I guess lah, but it doesn't matter. But can I tell you, it doesn't work. It doesn't work. Why? Because of the humidity in Malaysia. Every day we clock in a humidity about 80%. I'm not joking. I'm not talking about rain. I'm talking about just the air. Okay? And the air, the moisture in the air will seep into concrete. Because the first thing Matsan said is, concrete is by nature a cracked material. So if you have a client for some concrete house that you're building or whatever and you want it, and they complain about a crack, some hairline crack, some fine crack in the concrete, then they say, I cannot stand cracks. Never build such a house for this client because it is the nature of concrete. It's like our face. Our skin has cracks and fissures. There's no way you're going to get it porcelain smooth, okay? So by nature, it's a cracked material. Moisture will seep in, whatever the grade. You see, architects like to ask this weird question. Wow. Instead of grade 35, can we increase to grade 90? Forget it. 90 also got cracked. 100 also got cracked. 1 million also got cracked. Forget it. Right? So when the water seeps into the concrete, right, it will touch the rebar. The rebar will rust. And when rebar rusts, this is very interesting, it will expand 3 times its original volume. That means if a bar like that, it will expand to grow to 3 times its volume when it becomes rust. And just like the Incredible Hulk, it burst out of his underwear. Okay? So then what will happen? Because of the force of this expansion, the concrete will crack and spoil. This is called the spoiling of concrete. That's why the earlier picture you saw, the concrete had drop off lah. Okay? And guess what? This problem is like cancer. It's everywhere. All over 50 stories high up. Now, then, sorry to say this, MAPE, I think you're here and sponsored too. I think I'm talking to the wrong people anyway. Or Fosro or Sika or whoever, okay? So you say, okay, can repair, we have MAPE product. So what's the product? The product is go to this rebar, hack off whatever loose concrete, brush, clean, shiny, paint, Ferracoat, Ferraguard, Sika, whatever, MAPE, whatever. Then patch back with super duper, whatever lah, monotop. For Sika, it's called monotop, whatever top, okay? MAPE, another name. And put all this, then very happy. Okay, now you can be happy. Maximum time you can be happy, 3 years. It will happen again, and again, and again. And how do I know this? Not because of Troika. I will show you, okay, I think most people know us for designing flat slab high-rise, but you don't know something else that we do. We are just problem solvers, okay? So this guy called, okay, now I won't talk about this guy first. So this client, he has this resort called Ritz-Carlton Langkawi. It's a resort, it's not high-rise, right? We didn't do this building, okay? We know nothing about it, but the client one day just called up and said, we hear that you can solve problems. So this is the problem that we have. The Ritz-Carlton Langkawi has the highest room rental rates in the country. It retails for, it rents for about Malaysian 2,500 ringgit per night. And guess what? All these rust things you see in the concrete happened 1 month before the contractor hand over the project. That means not even, not even after handover, how many years? Okay, then, see? Look at that. Can see all the rebar. You see, the concrete has spoiled off. The spoiling problem that I told you about just now. Then you say it's because of the sea. Don't blame the sea, okay? It will happen, it will happen faster near the sea, but it will happen here anyway, right? Okay. Look at that. As a client, would you like this? 1 month before handover? Guess what? The contractor had repaired already. 2 rounds, fail again a few months later. So client give up, client call us. Now first and foremost, the workmanship of the concrete is terrible, right, Mr. Lim, Mr. Tang? The cover is not enough, but you know what? Sorry I hope nobody here is from Langkawi or from an island, but that's what happens in the island. You can't get very good. It's like a cartel, you must go to only we must only go to one contractor called Mr. Ng in Langkawi. Even if you appoint somebody else, it goes to him one. Just believe me, okay? So, okay, so you see things like that happening, and then, seriously, look at this. This looks like it's an ancient building. It should look like the Georgetown jetty, which I forgive it, I know it was built in the 1960s. But look at this, okay? Okay? Okay, I don't want you to read all this, okay? I'll give it to you for free later. You don't have to read. Okay, I'll explain to you what happened. Okay, I'll explain all this to you later, okay? You don't have to read all this. I just put it here to show you that we actually do some work instead of just talking. Okay, so I'll tell you the reason, okay? The experience that I have dealing with this kind of problem is over a span of 20 years when I was previously with Web Structures, then called Rambo. I've left Rambo. Yeah. And the thing is this, we had a very lucrative job. I can tell you now, now I'm out of it, okay? And the job was also over because I killed it. Okay, the client was Mr. Ong Beng Sing, known for the Four Seasons resorts all over. And Mr. Ong and his company called HPL Properties has got so many resorts in Asia Pacific. For example, he owns 50 resorts in the Maldives alone, all of them on individual atolls, right? Now, let me explain the construction to you. All of them are over water villa. They retail for about USD 1,005 a night. Okay? In the Maldives, there are 3 types of construction. Concrete, that means the stilts of the villa and the beams are concrete. Okay? Very rarely, some are made of steel beam. Okay? The third is also quite common, using pine logs, marine pine logs from New Zealand, grade H6. It's just the pine tree, and they use this timber everywhere. Okay? Now, so the first project that I ever did for them, I don't know whether I have the slide here actually, I'll try to look for it later. Let me see, okay? Okay, we'll go back to this later. I'm showing you all high rises, okay? Sorry, guys. Okay, I think I don't have it because I think I left it all with Rambo Web Structures, okay? So I just have to let you imagine a beautiful blue sky, white sands, and villas on water, okay? Now, the first Four Seasons resort that I worked on there is called Kudahura. And the concrete was all spoiling, right? So we did that standard repair that I told you using Sika Mape, whatever. And then we were so happy, and he paid us. Very good job. He pays us per hour in USD rate. Okay? And we were happy for 3 years. Guess what? After 3 years, same problem happened. And this continued for how many years? 20 years. So I do have some experience in this. Okay? And not just on Kudahura, on many, many resorts. We didn't work on all 50 resorts, but we worked on at least 12. Now, these were not, even on buildings that we started from fresh, with the additive to concrete for marine. Four Seasons resorts in the Seychelles, on the Petit Anse Bay. We did it for him, 75 hectares. We were the original engineers, we built it from scratch. We did all this, the problem still happened, right? So, what's the story, okay? I don't want to show you all this. I think I'm jumping the gun, but I just want to finish what I'm saying, and then we can see all these nice pictures later, okay? As you said, we're not here to see nice pictures, right? Okay. Okay, I want to tell you something. How do you stop this? Okay, so I'll tell you the story of Kudahura and the Seychelles. After about 15 years of doing this job, very lucrative jobs, I think I became a bit silly. Okay, I said, I want to find a permanent solution for Mr. Ong Beng Sing, who doesn't need my financial help. So, after much searching and research, I found a product. Okay, please, I own no shares in this company. I'm not selling it, it has nothing to do with me. Okay? I found a product invented in the USA way back in the 1970s. The product is called Acheron 7000. Okay? Way back. And what I read is that in Portland, Oregon, in the USA, there are marine structures that have survived more than 75 years with no problem. They look like brand new because they sprayed on this Acheron 7000. Now, what it does is, chemically, it's a colorless spray, looks exactly like water. I think my water is somewhere there. And it's a colloidal silicate product. This word, colloidal silicate, okay? And what it does is, it penetrates up to 200 millimeters into concrete. That's 8 inches into concrete. You just spray it. You don't have to do anything. Just spray on it. So it penetrates 200 millimeters, and it creates an alkaline matrix and traps every water. You know, it creates an alkaline matrix all around the steel bar, right? So that it will never rust. It was very hard to find it. They're very secretive about it. After much hunting, I found that it is today manufactured in New Zealand by the M.I.E.M brothers, right? And I'm not selling this, I have no shares in this, I promise you, but it's an amazing product. I tried out first. I use it to solve all the Four Seasons resorts in the Maldives. Ong Beng Sing never call me anymore. No more job. No more job. Seychelles also, no more job. Ritz-Carlton, Langkawi, different client, okay? AJ Resorts. We did it once, also no more job, finished already. Problem solved, that bad problem that you saw. All right? So it's such a wonderful product, but it was very expensive for Ritz-Carlton to use it because the M.I.E.Ms exported it, carried it, air freighted it to Malaysia, together with some Australian, New Zealand supervisors who were paid a lot, and they spray it. But after I saw them spraying it, I said, sorry, La Hong, you can spray it, I also can spray it. Because the beauty about it also is that it's safe. Guess what? You can drink it. I kid you not. It tastes horrible when I drank it, but you can drink it. I didn't die. I'm here today. Okay, so the thing down here is that I'm not selling the product, right? But the solution to that troika problem you saw, right? We help them solve the problem. We're going to spray all of this now with Acheron 7000 to stop the rot inside. And those things that have spoiled off, we have to do other things to it. But to stop the root cause of problem, we have to do this. Okay, so you might like to research more about this colloidal silica thing. But to any, okay, Hong, I really hope your building is okay. But the test of it is not now, you know. It's in 10 years' time, 15 years' time, 20 years' time. So my talk is about this durability over many years, okay? Anyway, I'll just flash through some of these things. We did, okay, another thing that people, we did this, I call it dog house, like in Broga, is for, what's his name? BC Ang and Wen Xia, okay? I think they call themselves something, last time it used to be BC Ang Architects, but I don't know what they call themselves now. So when we cast, this is very simple. There's no treatment, no nothing, no concrete sealer, no nothing. The slab is 175, 150 mm thick. But there was this thing, I think architects sometimes have this vision or imagination that when you pour concrete from the top at such a steep slope, they will all roll like water down here and then form a clump. I want to tell you by showing you this picture, it does not, okay? It's fine, okay? Because you can control something called the slump. Okay, I don't want to show off the structure here, but it's a cantilevered thing here, which is quite interesting, okay? Okay, Of course, we did this job. I think everybody knows about it. This is the pyramid factory in the forest with John Bulcock, the architect. And John always uses plank formwork. That means the formwork is using the plank finish so that the plank, the imprint of the timber plank is on it. And why does he use this? It's very forgiving. So you don't need to make it so smooth, so straight, because it's got this in and out and ready, so it's more forgiving, right? Still hard to do, but much easier to do, okay? Right, Mr. Tang? Okay, so that's it. We won't talk about the structure. I think I've talked about this very often. Okay, part 7 that we did, where I met you, Mr. Tang, in 2005, right? Very ambitious plan by CSYA, Sunny Chan Architects. The first 19-story cast in situ fairface. Now, precast you can control so that it doesn't look like tandoori bread when you go up. But this is a cast in situ, okay? End story, I would say Mr. Tang and Al-Ambia did a very good job in the basement. That's why he's so good for your GDP campus, because way back he was experimenting with how to make the concrete look acceptable to Sunny Chan. And he spent tons of money grinding, sandpaper, whatever paper you were using to grind, okay? IGEM built the upper part, the superstructure, right? And actually it was just like normal, just with concrete sealant, right? But guess what? The purchasers didn't like it. They said it looks cheap. So Kim Tae, STB Properties, tried to make it look a bit more atas. And she bought a very atas material. It's chem coat, very expensive Japanese product. It's a 5 mm render. You may not know it, but you see that lightish yellow thing you see? It's quite transparent, slightly yellow only. It's a render that's beautiful, like the way the Japanese do it at 5 mm, but it's not cheap. So after doing it, they kind of accepted it. But in retrospect, guys, I tell you, I'm quite glad that this happened. That it was not totally like fairface with concrete sealant, because I'll get more phone calls like her phone call. Okay? Again, it's not our problem, but I told you we learn when we solve other people's problem. Okay? Okay. So I think I'm going backwards. Okay, this is not fairface, but I would say the casting work is also pretty good and very ambitious kind of concrete work in Media City with GDP, right? Okay, this one I want to show you. This is Tokyo Marine Singapore, which we did when we were previously Web Structures. Okay, this is quite like Troika. The most for the, all these are structural elements, they're not decorative. They support the entire building, and they're actually tilted left and right and leaning a little bit forward and backward. Now this one, the formwork, 3 sides of the columns are precast panel. 3, like forming a C shape or a U shape. And the 4th side is not. It's traditional formwork, then you pour in the cast in situ, okay? But quite well done also. This one also very well done. So far, no problem. So all these are the secrets. They look very boring because architects don't like to see words. That's well and fine. But if you want to understand all this and all that, we'll give you all the contact, or you can Google yourself this. Okay, today Acron 7000 is available in Malaysia. I linked it up with an applicator here, and you can use it. So we don't actually, we make quite good money from solving these kind of problems, but I would prefer the problems don't happen in the first place. So please try to consider using the Acron 7000 when you're doing this concrete, then you don't get a headache. You won't get a headache. Like, I think for shorter buildings, right, the problem will happen a bit later. If the workmanship is good, it won't happen for even 15 years. But it's very hard to ensure that every contractor is as good as Al-Ambia. It's very difficult, right? Because they tender, then you must get the lowest tenderer, right, who doesn't know anything, you know, never heard of Perry, never heard of Doka, never heard anything. Okay, so I think that's it. I think I'm ahead of time. Okay. Okay.
So thank you so much, Engineer Ng Pek Ha, for your very entertaining presentation. I think we definitely learned a lot as to why those things happen, especially where concrete is concerned. And now, ladies and gentlemen, I'd like to invite our first sponsor's representative, Mr. Shivram Bagadi from M.I.E.M, Malaysia, Sdn to introduce their product. Can I please have Mr. Shivram on stage? I don't think you're Mr. Shivram. Huh? You don't look like a Mr. Shivram to me. Misinformation. Huh? Okay, thank you so much.
Right. So there's a miscommunication here. Mr. Shivram is actually not well today, so basically he cannot attend this. I'm actually presenting on behalf. My name is Yong. I'm actually the senior manager for the project specifications from M.I.E.M Malaysia. So I'm glad to be actually sharing with you insights on the concrete industry solutions from M.I.E.M. So besides M.I.E.M, we do have waterproofing, as you know, and tile adhesive and maybe concrete repair products. And this is actually one of the segments that we also producing for concrete industry solutions. The next slide. Thank you. So before that, I would like to play you an introduction of video of M.I.E.M. Can I have the videos playing? Then you click on the video then. There's no video. Oh, okay. Then I'll probably skip it. Okay, so basically in M.I.E.M in 2024, we are a global leaders of construction chemical suppliers. We have actually turnover for 4.4 billions with 98 subsidiaries for over 59 countries in 5 continents. And basically we have also 39 R&D centers in over 22 countries. We have 106 plants in 5 continents, over 42 countries. And as of last year, we have actually 13,200 employees. So basically, as actually not all companies has invested in the R&D, but M.I.E.M preaching is actually important. We actually believes in R&D. Our turnover of 5% goes into the R&D works, yeah. And in Malaysia context, we have our plant here in Nilai. It was actually fully operational in actually January 2015. M.I.E.M Malaysia started in 1994, and this is actually the plant that we actually started. And currently we have the plant actually in construction in Johor. So it is actually on the piling stage now. Right, so in this Nilai current plant, we have actually all the cementitious and liquid plant are producing here. And we have also the production and also the warehouse and also the product development lab. We also have the QC lab and also the technical service training room as well. So as you know, M.I.E.M solutions is actually across all sectors. Besides new building, old buildings, we do have solutions for even up to infrastructures and also big marine structures. Right, so today's insights on the concrete industry solutions, I'll share with you. So because basically all projects needs are actually unique, and all these applications are performance-based, and we can actually tailor-made to the requirements of the concrete requirements, and our solutions are basically sustainable concrete. And as you can see from here, our concrete admixtures, we have all these solutions here. Basically, we have all these silica fume, we have the retarders, we have the facets, we have the admixtures, we have the synthetic fibers. So this product range, they are basically can actually extend on the long workability retentions and also the usage of triple blend cementitious, and as well as the usage of the manufacturer sand. So in Nilai, we have the concrete labs, and also this is actually what we have in the facilities. We can actually do all the trial mix, right? And we can also provide on-site technical support, right? And all the projects, like you can see from the photos, we are one of the projects in KV MRT. And we also have the industry engagement, right, from time to time. And most importantly, as our philosophy is actually on the sustainability and durability, our products are actually certified by EPD, Environmental Product Declaration. So at the moment, I think these are the products that is actually certified by EPD in Malaysia. And we do have the solutions for low carbon concrete, yeah, for your information, right? So, and also, as well as we have another extension line called Recon line, a reconstruction on the concrete. Basically, when you have actually rejections on the concrete, right? So they will actually go back to the plant. And what will be the solutions is we can actually adding, things that to reconstitute the products to make it as a recon concrete, yeah, to minimize the wastage of the environment. Next, M.I.E.M also developed a carbon footprint calculators, actually in lines with the government's ESG compliances. We have this carbon footprint calculator. Actually, these are actually available in our website. Of course, if you can actually need assistance, we can always tailor-make and actually run this for you, for your projects here on the concrete solutions. Okay, let's take a look on the selected projects of special concrete references here. Right, one of the globally projects that we have done, this is actually back in Italy, our in-office. This is actually done in New San Giorgio Bridge in Genoa, in Italy. It's a symbol of hope, yeah, and it's actually a new bridge in just 13 months. Right, so what is actually interesting about this project? It is actually using our M.I.E.M Fast Ultra, which is actually be able to demo after 16 hours of formwork, yeah, even in the middle of the winter. So that is actually how our technologies can actually do in just 13 months. Besides that, we also involved in the Africa project, which is actually the Grand Ethiopian Renaissance Dam project. It's one of the largest dam in the world, yeah, and is what we actually supply here is actually on the roller compacted concrete, or we call it in RCC placement, yeah. Okay, nearer to this part of the world, we have the Tuas Finger Pier project in Singapore. So this is actually a super caisson casting with slip form concrete. We actually fix the stiffening time. Yeah, this is actually the slip form construction was key criteria is actually to get the stiffening time correct with other concrete performance. Right, we also have done this in deep tunnel storage system, or we call it in DTSS phase 2 in Singapore. Right, we managed to actually come up with these solutions with microbiological induced corrosion resistant concrete, or in short, we call it the M.I.E.M, right? So these are the sites, the supports that we actually provided for this DTSS2 in Singapore. Next, we have this Cross Island MRT line, or we call it is CR105. This is actually in Singapore as well. And the challenge part is actually the diameters of the tunnel is not the usual tunnel size, which is actually 6 meters. This is actually double the size of 12.2 meter. And what we actually supply here are the products that you mentioned on the Dynamon, which is actually super plasticizers, and also the demolding oil, and as well as the epoxy coating, yeah. And these are the what we actually do at the tunnels, right, between this and. Next, closer to home, we have done this for KV-MRT2. All the underground stations, they are actually using our hydrophobic waterproofing admixtures. We call it Hydrocrete WP. And of course, for your information, we do have the crystallizing admixtures as well. It's called Hydrocrete KR1000. Right, so there are also some special concrete needs that we have done in the shrinkage compensated concrete. So we have done this for the customers of JSN, T2, and the China Construction. This project is actually AT&S in Kulim, is a factory. Right, the ready-mix producers actually Buildcon, and we produce these Expandcrete products here for this project. Right. In conclusions, MAPE's actually philosophy is actually simple. Let's build more with less. By leveraging the research and innovations and sustainable solutions, we can actually create a durable infrastructures, reduce the carbon footprint, and also improve the efficiencies of construction. Thank you very much.
Okay, good morning everyone. I'm Sam Yap from YTL Cement Quick Mix. Thanks for Pam giving an opportunity for me to present my insight here. So today I'm going to present is about bringing the wall finishes. Okay, this is our full range of our products, but usually today we are going to talk about full range. We'll talk about few products only, specifically on our render and skim coat and also our non-shrink grout technical mortar. Okay, before I start my slide, let me have a brief introduction of our Quick Mix. Quick Mix is fall under YTL Cement, one of the divisions, and all our product, we have a Serum Eco label, low VOC, less than 5% of all our product, and also we are following with the ESG trend. Okay, so in our Eco Dry Mix, we also have our own laboratory as well. Mic, thank you. So we also have our own laboratory. We do our own R&D testing, and also any complaint, site complaint and site issue, we also have our own lab to test out. We don't need to go for third party. But for certain testing, we have third party, go for third parties, okay? Okay, so I'll talk about three biggest phases wall challenge faced by architects, contractor or developers lah. Okay, the first one we'll be talking about the shrinkage crack. Usually, shrinkage crack it will be happen usually because of water retention is not enough, fast setting, and also wrong product and also application method lah. As you can see from the slide here, I show we have two main method in our industry. One is the site mix industry, site mix application method, and the second one is the pre-pack. So in quick mix, we have another alternative, which is the dry silo mortar. The dry silo mortar is for project that need faster, more efficiency, and also product QC control with a less product issue. So for this silo dry silo mortar, I won't go into details, but what we can pump out from this one, you can pump out from renders to skim coat to anything plastering finish. Second, delaminations. Delamination, I believe, is a very common issue lah. Usually due to excessive build-up and also very smooth surface require another bonding agent or mechanical key coat. So for our render, we have a special render that can do up to 15 mm per layer, and also we have a varieties of render finishes. Poor additions due to thickness too thick, I think is at least more than 30 mm per single layer, which lead to the bonding issue, one of the main issue lah. Then for our product can also be inserted into the dry silo mortar for the project wise. But for pre-pack, this is a pre-pack version we show you, and then we have a two version. One is the coarse, one the semi-smooth version. So the tensile strength for both product is 0.75 Newton meter and above. Okay, so can up to 20 mm thickness. Per layer is about 10 mm. Okay, so this is a little bit tips during plastering to avoid delaminations, debonding, and also cracks lah. Surface preparation, example, mixing, weather condition has also play a big role, and also curing time, especially curing time. If you want to reduce shrinkage crack, curing time is very important. Okay, and also the thickness, bonding layer, and final applications. If you can see from here. This is our, okay, this is just a normal design tips maybe for the specification guide or the BQ. For renders, you can go up to 10 mm per layer. Like example, for our 386 Plus and 387 Plus, we can go up to 20 mm. Okay, the next one after plastering will be skim coat. Skim coat, usually we have three major issue cracks. One is cracks, uneven surface, and powdery. Okay. So for scheme code, usually we have a general, for manufacturer, we have a general specification. Thickness is 3+2. 3+2 means 3 mm base coat, 2 mm finish coat. So to ensure this one, to ensure the thickness, why we follow thickness is to ensure the thickness durability and also the addition. Too thick, you will have powdery issue, or the thickness will be, they cannot be debond on the wall. Okay, so this is the second scheme code last product for external. What we usually heard is scheme code for internal. We have a scheme code for external. External, we have two kind of surface, semi-smooth surface and smooth surface. So for the semi-smooth surface, we have a hydrophobic performance, which means we repel water. So because due to fluorescence and mold happen due to the wall, external wall, is because of water penetration, rainwater. So for if you have hydrophobic, we can prevent that. And also for smooth surface, is usually due to this construction, near this construction, because we have a lot of inquiry that requires smooth finish. That's why hence we have a smooth finish scheme code for external. And also this is our advanced scheme code, alkalic type liquids are ready to use. And also you can see from the drawings here, he has a flexibility. Flexibility can tolerate stress cracks up to 0.05 mm. Okay, and also it is hydrophobic with water repellent. So it can reduce the mold and also cracks and also the fluorescence. So next will be our technical mortar. We have non-string, we have the patching grout 218, and then we have the non-string grout 218 and patching grout 219. Sorry, thank you. The strength will be more than grade 50 and above after 28 days for both. And then also we have early strength up to 20. So this is the diagram, general diagram, how to proceed for brick wall and RC wall equipped with thickness. You can see from plastering, base coat and finish coats. So this is usually for a manufacturer recommended thickness. Can we go higher? Can we go lower? Yes, we can go higher and go lower. Depends on which kind of product you take. We have a kind of different product. So for details, you can find me later after the presentation as well. No problem. I'll be outside. Okay, this is our full range products. So thank you. These are my slide.
Okay, thank you so much, Mr. Sam. Yep, that really was quick, huh? Straight to the point. Thank you so much for that. And now, ladies and gentlemen, I'd like to call upon our third speaker for the day, Mr. Lim Zi Liang, who will present on off-form concrete delivering aesthetic and structural excellence. But just a little bit of a bio before I actually call him up on stage. Now, just to inform members of the audience here today, Mr. Lim Zi Liang is a general manager, technical at YTL Cement Construction Development Laboratory and Innovation Hub with state-of-the-art ISO accredited cement and concrete lab focused on advancing concrete techniques and sustainable construction solutions. With over 2 decades of experience in the concrete industry, he brings deep technical expertise and ground insight inside the evolving needs of Malaysia's built environment. So without further ado, I'd like to call upon Mr. Lim Zi Liang.
Good morning, everyone. Okay, let me start off my presentation today with off-form concrete, delivering aesthetic and structural excellence. So, okay, let me bring you through what is actually a off-form finished concrete. It's actually an exposed cast surface, architectural and structural finish, aesthetic appeal, durable, requires precision, and also supplier and contractor synergy. So in off-form concrete, why concrete supplier is important? Okay, our role actually we directly affects surface smoothness, color uniformity, workability and setting time of the concrete, and also very important part of this is mix design consistency. So let us go through recommended concrete mix design and workability for us to perform a off-form finish concrete. So we started with low water cement ratio. As you know, water cement ratio playing a very important part in our concrete mix design. A lower water cement ratio means a higher strength that we can achieve. So if we have a low water cement ratio, the purpose is we try to reduce our bleed water and porosity in our mix, and also less water goes in means fewer capillary voids, which minimize the bug holes formation, pinholes, and surface latents. So the benefit of this is with lower WC ratio, we can result in more dense and compact matrix with a smooth surface, and also minimize discoloration or patchiness from bleed water migration to the top of the surface, and enhance durability and improve our visual uniformity. Recommended concrete mix design by using a mixture that with a PCE base. PC is actually a new generation of superplasticizer and retarder that actually enhance the workability of concrete without increase the water content in our mix design. This allows concrete to easily place and compacted even at a lower WC ratio. So actually this is a very important key point that I would like to bring out. Is actually a myth that from the market saying that a low WC ratio means a higher strength concrete that actually normally is hard to place into the structure. So by introducing this PCE based admixture, we managed to overcome this issue. So the benefit is high flowability or self-compacting behavior while keeping the mix cohesive and reduce the segregation issue. So it also reduces honeycomb, voids, and cold joints in the structures, and also help us to achieve crisp edge details and define impressions from the formwork. So the third point that I would like to bring out today is by adding GGBS into the concrete mix design. So this GGBS is actually refines the microstructures of the concrete, and it also indirectly improves sulfate resistance and long-term durability of our concrete structures. And the benefit of adding GGBS as a supplementary cementitious material, it actually increases the high flowability while keeping the mix cohesive, and also can reduce the risk of having a honeycombing, voids, and cold joints in the structures. And of course, it helps us to achieve crisp edge details and define impression from the formwork as well. So number 4, we would like to stress is the fine aggregate control in the mix design to ensure uniform particle size distribution and cleanliness, and also reduce surface defects caused by segregation or contamination. So this produces a uniform smooth structured surface with fewer blemishes, and clean and well-graded sand minimize surface striking and rough patches. I think the previous two presenters actually showed us some photo of having a striking surface, which is mainly caused by the defects in concrete. So we have optional pigments or white cement that actually achieve specific color tones or finishes. White cement enhances brightness and color uniformity, and it enhances architectural appeal and meets design requirements. And of course, it also reduces the inconsistency in our common problem in our off-form finish is color shading across our panels or pouring area. So for slump and workability for off-form finish criteria, I think this is the key. Another point that we would like to bring the awareness to the market is target slump should be S3 and S4. This actually specified under our Malaysian standard EN 206. You can see from the right here, the table here, we can explain to you. S3 and S4 is actually having a slump from 100 to 210 mm with medium workability, and S4 at high workability range. So what are the benefits of having this slump or workability range is also to improve our visual quality with fewer surface defects, and also enhance ability to achieve class 1 surface finish, and also reduce surface patching and repair work after we demo our formwork. So slump and workability of off-form finish, we can see from here in the recommendation under the EN standard, EN 206 is actually mentioned that for any structural use concrete, our slump should be on the S3, which is 100 to 150 mm. I think we have to bear this in mind that those were the days that using lower workability like 80 mm, 100 mm are at the past. Then we should change our mindset, try to spec a correct workability into our concrete mix design to ensure we don't have more surface defects in the future. So let me bring you through what is the common defects tied to our concrete supply. So we can see from here, this is very common happen in our job site, that we have bug holes, we have color variation, co-joints formation, surface latence, and strength streak. So let us share with you some best practices as a supplier. First, we try to maintain tight quality control at the batching plant. So I mean, that is the most important point. As a supplier like us, ready-mix supplier, we must ensure we have a strict control over our raw material selections. Example like cement, aggregates, water, and mixture. And we must ensure the batch-to-batch variation must keep to a minimum rate. So moisture control in our aggregates, I think this is another key control that we have to implement at the batching plant. And this is to ensure the intended water-cement ratio is being maintained, and also variation that occurs defects like latence or color differences. Third is calibration of our batching plant equipment and weighing scales must be done regularly to ensure precise dosing into our concrete mix. And the last one is control on our mix design, mixing time and discharge sequence helps avoid segregation and ensure a homogeneous mix. So for your info, actually in Construction Development Laboratory, we also have our academy, call it as CDL Academy. In this CDL Academy, we actually plan to work together with all the stakeholders in our industry, including architects, engineers, and all other suppliers as well. Even if our competitors, we are willing to share our knowledge with them. So, example, to educate our client teams on site handling, we actually come up with a few points to share, which is first one, foam release oil. I think that is a key parameter. Later, I think Mr. Tang will agree with me in his presentation that a selection of foam release oil is important for us to achieve the off-form finish products. And vibration technique, pouring sequence, I think this is another important point that I won't touch in more because I think Mr. Tang has more experience than us, how to do a pouring sequence, and also formwork quality awareness. I think during the break, we have actually a brief discussion on this. We will let the expert like Mr. Tang to share with us later. So foam release oil, let me bring you a little bit insight of this is a detailed application of the release agent that actually gives a best result in terms of color uniformity and also minimize the quantity of release agent that we can have a better control of the dispersion, and also synthetic and vegetable release agent produce better surface. You can see from the photo here, the formwork release oil actually play a very important role to have a smooth surface. And also vibration technique, you can see from here, there's a lot of honeycombing here, and perfect vibration, we should have a near to perfect condition of the wall. So a clean steel formwork thoroughly before each concrete pour is very important, and we need to apply more release oil evenly to prevent surface sticking or staining, and seal all formwork joints and gaps properly to avoid leakages and edge defects. You can see from here the edge defects that we actually showcase at here. And the last one is technical factors in casting off-form finish. Actually, the most important part is formwork quality and mixing and delivery variables. This one, I think mixing duration and sequence influence homogeneity in our concrete mix design, and transit time to the job site and drum speed affect our slump consistency. And temperature control during delivery may be crucial for us to take into consideration, knowing very well the temperature in Malaysia is typical hot climate, that our concrete temperature is going to be very high as 35 to 36 placing temperature on site, delivered to site. So I think that's another key part that we would like to control the temperature in order to minimize the crack formation as well. So curing process is equally important, that inconsistent curing can cause our discoloration, plastic sinkage crack, and different type of sinkage cracks, and also type of curing compound can also have a discoloration issue. So selection of curing material is very important as well. So environmental challenges, as I mentioned earlier, rain, which have a washout effects, staining on our structures, heat, that fast evaporation and cracks formation, humidity affects our concrete setting time as well. So visual consideration, okay, tie rod planning, form lines and joint must be coordinated with architect, and surface uniformity and reinforcement setup team coordination and planning with our CNS consultant. So let us bring you through my last point of presentation is sustainability in off-form concrete. So actually what is sustainability in off-form concrete finish is we try to use more eco-friendly approaches like have a Portland limestone cement, PLC, supplementary cementitious material including of GGBS and silica film, and incorporate recycled aggregate in our concrete mix design. Just for the info for the floor, we're actually having the first repurposed concrete center, which we collaborate with CREAM, the research arm of CIDB, that in Chan Sao Lin, that we actually try to reuse back whatever leftover concrete that sent to job site, and we try to recycle, repurpose it into recycled aggregates. So this is to support our circular construction practice. So use low carbon admixture, PC admixture, as I covered earlier in my presentation, which is suitable for further minimize the embodied carbon and allow for lower cement water cement ratio without sacrificing our workability, and also enable cement reduction while maintaining our strength and finishing quality. And we also would like to promote performance-based mix design that balance aesthetic, structural, and sustainability requirements. We encourage the use of local raw materials to reduce transportation emissions, and also we support compliance with Green Building Index and other green certification frameworks like LEED, MyCREST, MyHEW, which is available in the market. And let me end my presentation today with a quote: "Great architecture is not built alone, it's cast through collaboration, material mastery, and a shared commitment to excellence." And from here, I would like to thank for your time, and thank you. That's all from my presentation today.
Wow, okay, another very quick presentation. Thank you so much, Mr. Lim Zi Liang. That was very insightful, very prompt, very valuable. And now, of course, our final speaker of the day, very much on time, much earlier in fact, is Mr. Tang Juang Yu, presenting on form plan to finish, a contractor's approach to fair face concrete. Now, of course, before I invite him on stage, I'd like to give you a little bit of a bio as well. Mr. Tang Juang Yu, born in 1957, and a native of Kuala Lumpur, is a third-generation professional in the building and construction industry, inspired by his grandfather and father, both building contractors. Mr. Tang began his career in 1974 with BEP Architects, where he gained early exposure to architectural practices before progressing into technical and site-based roles, and has started to as a draftsman and later qualified as an inspector of works in foundation project execution and site management. So he's clearly got a wealth of experience behind him, and I'm very happy to now invite him on stage, Mr. Tang Juang Yu, our final speaker of the day.
Which one to press? It's okay. To shift the, how to press this button. Good morning, everybody. My name is Tang from Al-Ambia. First, I will give me the opportunity to address all the architects, which I call them dreamers. What they draw and what they dream is two different things, I suppose. Okay, let me start off with constructing fair face concrete. It's okay? Yep. This is the GDP campus. Doesn't move. I think for fair face concrete, we classify under 3 stages. Number 1 is design, material selection, and construction method. If the design is not designed for fair face concrete, which is difficult for contractor to achieve. Okay, let me touch on the first stage is the design. I think for the slab system, the architects or the engineers, it's easier for fair face concrete is to design a flat slab. For flat slab, we will have less joint, no beam connection, so easier for us to cast a column. If the beam running 2 directions, having different height, it's quite difficult to get a column in the fair face finish. Second one is the geometry. Complex geometry should be avoided, like different size beams, which Big Ha is laughing. It's like his capsule. His capsule actually gives us hell. Okay, for any groove line, you cannot have a 90 degrees groove. You have to be tapered at minimum 7 degrees. If not, we cannot remove the formwork. For beam design, as I say, is that post-tension beams and slab should be avoided because of the stress head, and those things will damage the fair face concrete. Also touching on designs, I think the perimeter wall length have a limitation. I think PAM building is 51 meter long. That's why you see a lot of cracks along the wall, which I think Big Ha will agree because of the shrinkage and expansion. Window width, now I think YTL have came up with flowable concrete, which I think can resolve this problem. Why we say window is not 1,000 meters or 1,000 mm, okay? If it's the window is bigger than 1,000, you will have honeycombs or concrete that cannot flow under the formwork. But I think with the YTL coming out with the cell compaction and flowable concrete, this probably can resolve this problem. Floor height. The architects have to remember that because you have designed the formwork in certain patterns, if you start changing floor heights, the cost and the time will be involved, because we have to strip the formwork out, redo it again, change all the tie holes, and it costs money, especially GDP Architects office have 4 levels, which costs us a lot of money. Staircase core, I think the engineers also should agree that the staircase wall butts against 2 RC wall. Try to have the design of the staircase is from landing to the slab. Don't depend on the 2 side wall to take your stairs. If not, you will have a lot of bars coming out from there. Oh, I did move this slide, I think. Anyway, it's slightly different from my things here. Okay. This is also touching on the design on M&E positions. The M&E position should be decided early or prior to concreting. There's no room to adjust because it's fair face concrete. For example, the lift call buttons, the telephone, bomba telephone, or the switches, it have to be confirmed before we cast the concrete. The second item we're touching on is material selection. For fair face concrete, actually steel mold is not recommended because the steel mold, after a few times used with vibration, I think the steel mold will deform. It's very difficult to get the steel mold as flat as a plywood. So plywood, unfortunately in Malaysia, we unable to obtain first grade plywood. So for PAM building, actually the plywood we got it from is from Doka. if the plywood come from Finland, which is costing us like 400 ringgit per piece, 18 mm. For GDP campus, we use Perry plywood that come from Russia. Fortunately, Perry have some stock, so they sold to us at half the price, which is 350 per piece. Normally, if we import directly from Russia, it will cost you about 650 per piece of 1.2 by 2.4. Come to concrete design mix, I think Mr. Lim have emphasized, which I don't want to touch too much on this. He's the expert in concrete. Concrete material storage. This is something also very important. The raw material should be under cover because of the water-cement ratio. If your sand and aggregate are exposed, before the night when there's rain, and next morning you start patching your concrete, it's very difficult to control water-cement ratio. Sand quality also have to be minimum silt content. So if the silt content is high, I think the patching plant have to pour water and bring the silt down. Cement, type of cement. The type of cement, I think, is minimum blended cement, which I think Mr. Lim also disagree now. He said his cement and his blended cement are well controlled nowadays. Type of cement is the concrete supply. This cement must come from the same plant, preferably, because different manufacturing of cement have different clinker, which the color change. So concrete supply try to get from the same patching plant, which both this project, PAM and GDP campus, is supplied by YTL, and from the same plant from PJ, I think. Cement consistency is we encourage to use OBC, which I think YTL will have come up with something better than this now. Release agent, I think the architect have touched on release agent for formwork. For formwork release agent, we recommend highly non-oil based. It have to be water based, because oil based will change the color of the concrete. And for using water-based, you have to apply this release agent 24 hours before you put up your formwork, because it doesn't last long. You cannot brush the release agent and leave it for a week. Okay, we touch on construction method. Don't know whether I'm an expert or not, I'm still not too sure, although I built 2 buildings only of fair-face concrete. Okay, for spacers, actually, we cannot use cement or concrete spacers because you will see the patch. So all spacers to be encouraged using plastic spacers. And we also want to touch on this, which I don't know whether touching on Pekha's directory. For any wall, say it's a 300 mm wall, the normal concrete cover above ground is 25 mm. So if it's 25 mm from the main bar to the surface of your plywood, you minus a secondary bar of 10 mm, you left with 15 mm, which aggregates mostly comes in 20 mm. So you will find a lot of honeycomb aggregate stuck between the bars. So the engineer have to actually allow a minimum 40 mm spacer. So you reduce your strength, so maybe you have to thicken your wall. He don't let you, then you have to increase your concrete strength to grade 80. Okay, this one we touch on the rebar continuity. Give you an example of PEM building. Actually, PEM building, because of being a bubble slab, so it's not an in situ flat slab. That's why in PEM building you see 2 lines. The line below the slab and the line above the slab, which is happened in PEM building. For GDP, maybe they are smarter using Pekha to come up with flat slab, 200 mm thick, spending what, 16, 18 meters. Okay, so if you use flat slab, I think the architect and Pekha also have mentioned that we use the Pekha box. So we will cast the wall above the slab or same line with the slab. But for GDP, this drawing shows is we are above the slab because GDP have another 150 mm raised floor. So our line will be in line with the raised floor line. So for normal, without raised floor, I think the top of the column or the wall have to be top of your slab. Okay? In order to get a very straight line from the top of the wall, because you're having different levels, different numbers of column, so we actually fix a timber. I'll show you the next photo. Okay, this one is, I think, the architect and Pekha have mentioned the Pekha box and the coupler, the mechanical coupler for reinforcement. Okay, come to this construction method on plywood panels and screw. So as I said, the plywood have to be good quality. None of the local manufacturer here, even Perry bringing from Vietnam, you still cannot fit the quality of plywood for fair face concrete. I think if contractors are here, they will realize that even before you use the plywood, after fixing, for the next 2 days, the plywood start to deform because of the quality of plywood locally here. And the screw of the plywood, so the screw have to be all in line. Once you remove, you will still see the screw dots at the fair face concrete, which you cannot cover unless you patch it up, which you defeat the purpose of fair face concrete, I suppose. So the contractor have to actually line all the screws straight, and the plywood actually is not M.I.E.M, it's a mistake. It's normal plywood, deco ply from overseas. When we do the plywood joints, joining two plywood together, this is only our experience. It's not something technical or specification. We actually use a double-sided tape. Before we nail the two plywood together, we line a double-sided tape, then only we put it together and we screw it. So this double-sided tape will help us that there will no concrete or water flow, the cement flow from the plywood joints. This is not the rocket science. Maybe other contractors can come up with better ideas. Okay, as I mentioned, how to get the top of the column or top of the wall straight, you have to nail 25 by 25 mm timber, which that line have to be very straight. That will control your concrete level, which is relatively very straight, because no matter how you trowel it, you cannot get it straight. So after that line, at the back of the line, your concrete can be varied. It's not too important, but the line when the two plywood join back, that line have to be straight. So we use a 25 mm timber as a guide to control the line. This photo, I think you have seen, not necessarily you have to use Perry, Doka, Zulin, or EFCO. There's many local suppliers that are supplying this type of formwork system. So the railer beams and the screw and the nuts, or we call the tie rods. So these tie rods have to be decided early by the architects. But there is a maximum distance that we can go because of the railer cannot take the deflection of the concrete. Unless you change it to the I-beam, which I think is very costly. So there's a limitation about the screw holes. And the screw holes also, you have to make sure that it's all equal. From the plywood, each of the plywood come out, whether it's 150, 200, all this have to be decided by the architects. And that have to be consistent. If it's left 150, right 150, bottom and top also have to be 150. These are the cones that we used to lock the formwork. And behind this cone, there will be a PVC pipe so that you can take your tie rod out. And that PVC pipe have to be heavy duty. Because when you lock the formwork together, there will be a compression. If it's not heavy duty, the PVC pipe will bend. Then your wall thickness will be inconsistent. Okay, for concrete casting, we encourage that we should cast it in layers. Up to every pour, you should not exceed 600 to 900 mm layer. Then you go on layer. If you let the concrete flow by itself, somehow you will see the construction joint. I mean the concrete flow, the joint there. For vibration, you have to use two vibrators. One is internal and one is external. Because the external vibrator will cure a lot of honeycomb and air bubbles. You will prevent air bubbles, which I think a lot of architects like air bubbles. It's part of fair face concrete as a whole. Interfacing with architectural elements, that one again, the architect have to really special care on the concrete, the wall joint with other finishes. We encourage to have a groove line. No matter how RC wall joint with a break, I don't think you can get it perfectly straight because the RC wall might not be perfectly vertical. So with the groove line, you will eliminate the joints problem. This one, engineer Pekha's geometry capsule. Actually, this is a very challenging slab that you design, which make, I think my Taiko is here, though he left us, but he's in charge of GDP campus, Lau Po Kiong, I think he's here. So it's challenging, this capsule. Okay, basically, actually, we have to use a 3D modeling to model it out. So in order to get all the plywood size and position correct, if not, the lines on one hand, left and right, will not be in line. Touching up. We have developed a skill which I'm going to wash Lau's brain so that he will not know how to repair fair face concrete, because no more with us. You look at one of the photos, you see the concrete surface, and on the right, that have been repaired by us. And okay, one more thing is, once you remove your formwork, immediately you have to use a sandpaper, fine sandpaper, very lightly sand the fair face concrete down, because there's some stain or anything which you can remove immediately, but it's after a week you can't remove it. This is too long. That's why we couldn't remove most of the lines out. Conclusion, that's it from me.
Okay, thank you, Mr. Tang Yuan Chu. Can we please have a round of applause for all the speakers so far? I have to admit, especially our last two speakers were very prompt, very quick, and very, very efficient. Conclusion, that's it for me. That's wonderful. It's a great way to end a presentation. So at this point, I would like to call upon all the four speakers to please come on to the stage for the Q&A session. Can we have our four esteemed speakers here on stage, the ones that you see? Mr. HEW WAI HONG, Engineer Ng Pek Hor, Mr. Lim Ziliang, and of course Mr. Tang Juang Yu. So we've got a Q&A session right now. And of course, the members of the audience are invited to ask whatever that you like. Now let's just double check and see, are we doing a Slido thing today, or is it just straight from the audience? Can we get confirmation from our organizers here? Let's get it confirmed and then we'll proceed. So straight to the audience, sorry? No Slido. Okay. So this is what you need to do. We're going to have a moderation session begin here. In the meantime, though, there will be a point where we will ask members of the audience to please stand up. Mics will be given to you. Please introduce yourselves and who the question is for. Okay. So without further ado, I'd like to invite Architect Edric Chu to please lead our moderation session. Thank you.
Thank you, all the panels, for the talks. I've got feedback from the ground. It's a great talk by everyone. It's great sharing. That's our purpose. I mean, today's talk is to collide together between all the experts from different range, from architects, engineer, contractor, and the supplier. We have been hearing talk from the architects in PAM Center. Hardly hear talks directly from the suppliers and also the contractor, especially. So let me recap a bit what the speaker have talked about before I open the question to the ground. Hong was talking about the design intent of a GDP campus, how they actually plan for all the area, which area, and how the construction join for the off-form concrete. Meaning, if we want to design intentionally for off-form concrete, we have to plan and design strategically in the initial stage, where this one will pass to the engineer, where the engineer, Pekha, is talking about the problem with concrete, of course, certain challenge that architect like to dream and push forward for the engineer and the contractor to find a way to achieve it. That's where the contractor always scratch your head and engineer always find all the challenge that given by the architect is always out of the picture sometimes. So Pekha was telling us about the problem with concrete, that she shared one knowledge about the Acron 7000 that is applicable to the concrete in order to protect the concrete for the long run. We have Mr. Lim. Normally we hear supplier talk is about marketing their product, but this round we are different. We specifically hear the supplier talk about the importance of the mix and the understanding of the grid that in the concrete mix before you actually can spec, put inside your spec in order to achieve the off-form concrete that we want. So I think insightful from Mr. Lim is very important. And also they have, YTL have introduced a new concrete, as everyone knows, it's called floor mix, and also self-leveling, right? Yeah, which is actually good. Some of us like to design a complex form or some area which a lot of openings that very hard for the concrete to flow down to the odd corner that result of the honeycomb, which is Mr. Tang tried to avoid. And I mean ourselves, everyone tried to avoid. So Mr. Tang was talking about that, how sharing the knowledge, how his experience of putting out the concrete in different formworks that can actually help us to reduce and achieve the quality of the joints and also the surface of the concreting. Okay, maybe now I would like to open the question to the ground. Today we don't do Slido. Normally we do Slido, which is the so-called quiet way of asking question. I think today's is everyone is matured enough and to raise hand and ask if any challenges that you all face. We have all the panel here that are willing to answer all your questions. Thank you. Yeah, we have first Susanna.
Yeah, hi, I'm Susanne Zeidler and I'm an architect together with Lim Watt next to me. I would like to ask a question to Lim Tse Liang. I understand that in a market the cement and all this mixture, and we're talking about making like a bread mixture for concrete, is all gone through testing, gone through, silicate, make sure silicate is not in a sand. I mean, that is, I believe, by YTL and by the people. So then, Okay, so we trust that, yeah? And then a contractor go and buy cement, yeah? And so why is it still happening, yeah? That there are oil flecks after a while and the concrete is very poor. How can this happen?
Thanks for the question. I think to address this issue, I think we need a collaborative between from all parties involved. I mean, to blame solely on the supply of the material, I think that is not right. I mean, sorry to say that. I think we need to work together with contractors, we need to work together with architects, we need to work together with the designers of the structure, and of course with the supplier like us. We have to ensure we need to know how actually the whole methodology looks like, then for us to propose you a suitable materials or mixed design for you to use in your structure. No doubt we have carried out a rigorous testing in our laboratory. Like for our case in YTL Cement, we actually have a CDL, Construction Development Laboratory, that carry out all the testing, different type of testing, and we are all ISO tested.
So when this oil flecks, I mean the oil flecks is something you don't know in the beginning unless there is a silica test. So which means, I mean, it cannot be the workmanship, isn't it? Now purely on oil, purely on the oil appearance. That means the people where they bought the cement from, they haven't done the silica test properly. Is that true?
I think at my perspective is oil stand is most likely is from the, like what Mr. Tang said, is the release agent, more oil. That is something that we try to avoid oil-based release agent to be used, especially for off-form finished concrete.
Or oil, okay. Okay.
That is the stand actually coming from the oil base or wrong application, like what Mr. Tang trying to explain to us, earlier on.
Okay, thanks. Sorry, one more thing because I was
maybe Mr. Tang want to express the idea on that.
Okay, I mean, when we first built M.I.E.M Center, we didn't realize it. We actually use oil-based release agent, which we find there's a lot of yellowish lines and happening. So from there, we was advised by the supplier to use water-based. So GDP Architects buildings are all water-based release agent.
Okay, thank you. Okay, my last question is something totally different. What about color concrete? Can you say a little bit about, I mean, we see overseas a lot of color concrete used, like say, for example, red building, fully red, strong red color concrete, for example. First of all, what is the color made from, and would adding on color reduce the strength of the concrete in any way? Yeah, that's all. And in the market here, is it available, easy available?
I think for color concrete, we actually have a series in our Eco Series product that we actually add in pigment. It's a dry powder pigment that actually we source from third party that actually can add into the color like yellowish, greenish, reddish. I think that is one option. Another option that we can have actually a very light gray or whitish base of concrete finishing by introducing these GGBS into the concrete, not only OPC itself.
Susanna, I think I can add a little bit to this. When we did Troika, the panels, right, way back in 2005, there were 4 full-scale mock-ups. We actually built 4 stories of it at various locations because Foster was testing out the color of the precast panel, and to have different shades of color, we actually use a mix or proportion of ordinary Portland cement from one particular supplier and white cement. Okay, the white cement actually has no strength one. Okay, and then we also have a yellowish kind of, it came out quite a little bit yellow, the panel. And how did we get this yellow? I don't think there's such a thing as a yellow. So it's a slight pigment, slightly yellow. And then we had another one. Which was, I think it was a bit darker, a darker gray, which was, as you said, a different mix of GGBS and all that. And then after that, I think they didn't like the yellow one, I distinctly remember that. And then in the end, I think we went for the so-called grey one. And that's what we have today. So as to whether we can do it today, I don't know about crazy colors like purple or something like that. But these kinds of shades, I think we did it even then, yeah. But what's very important for Fairface, like you saw Hong, right? You need to do the full-scale mock-up. Without the full-scale mock-up, you don't know what you're doing. Another point to note is for the troika panels, you may or may not have noticed, there are no tie rod holes at all. There are no holes, and the panel is very big. It's 3.2 meter by 1.5 meter. So in the design, again, by the architect, they make our life very difficult for the contractor also. Because they say we have to tie the two panel, right, at the groove. You know, like the gap between one panel and another panel, they said to put there, but then we said, what are we holding? We are holding nothing because, you know, it's just the panel living there. So at that point, that was a kind of gasket. That thing was done in a gasket, and there was a special, like, spider-looking thing that we fabricated. I forget what it was, and I've lost the photo. Okay, I can't show you. But it was very, very difficult because the concrete is very heavy because it is 600 mm thick of concrete and so high up. So these were certain challenges, and that's the reason why a lot of money was spent with that orange-colored steel frame. They call it the strong back. It had to do all this stuff.
Yeah, we have another.
Hi, good afternoon. Sorry, before my question, could I just slightly address to the questions that was asked? Suzanne, I'm Oscar. I do the decorative concrete, so I have a little bit knowledge about pigmented concrete. In fact, we are doing a piece of purple concrete that would be up in one of the tallest buildings soon, and a piece of seat. It's a seating. So to answer your question, we're adding color pigment into it, reduces the strength. The answer is not really, because there's certain limits that percentage that you could add a color pigment into a concrete, whether or not if it's a white concrete or a gray concrete. And on top of that, the base of pigment are usually either chromate base or zinc oxide base. So these are the raw material terms that we are always looking at. So yeah, I hope that answers your question before my question. All right, sorry about that. I have a few questions. Initially, from the architect side, it was said that vertical units are grade 50, but M.I.E.M later on said the grade 50 is only at the round column. So my question is, in the photos, there's a lot of vertical panels outside of the building. Are those also in grade 50, or are those only in grade 30?
Yeah, I think I should take that. It's a structural question. I don't think we need to fuss at all whether this panel or that panel round or whatever the shape is grade 50 or grade 35. It's a very simple engineering thing. With grade 50, okay, in terms of the architecture, let's say an architect insists, okay, I'll give you a very good example. Park 7. I think you know this, everybody kind of know this building. It's a 20-story building in KLCC, an apartment block. The grid of that apartment is 9 meter by 10 meter, the column grid. And all the way up, the architect, Sunny Chan, CSYA, one of his key cast in stone thing is that all the column in the building can only be 600 by 600. You understand? So now, for a 20-story building with the tributary load given by this grid, it is at the lower floors, right, just gravity load, it's impossible. Even at that time, we were aiming maximum grade 50 for this building. So we couldn't support the building with a 600 by 600. An architect cannot give us any other size because must be same all the way up. Okay, so what we did was, we stayed with grade 50, or we could have upped it. There was an option to up it to 70 at that point in time. But obviously, we're not going to be the first in the world to go and do a grade 90 or in Malaysia. And it was too much fuss for a building that wasn't that big, actually. So what we did was a very standard traditional thing as engineers. When concrete can't work, you look for steel. So we inserted an embedded steel inside. But even the steel could not fit inside that's 600 by 600. It ended up, Mr. Tang, to be a built-up steel section. Grade 460, imported from Japan, took 6 months to come. And it was 100 millimeter thick of steel section. And so it looks like, to you, it looks like a very simple building, though very nice architecturally, but there was a lot of this stuff inside. Anyway, what was your question? Okay, so your question was about the fin walls at the side of the GDP campus. Those are I cannot say any grade will do lah. Okay, it's grade 35, but the loads weren't high at all at the fins aside. The heaviest columns were the round column, the circular column, because there is a largish cantilever at that side of that building. So we would just give it what we want. Okay, I also mentioned another one, though this is not concrete, this is steel. That pyramid building designed by John Bucock, right? The factory in the forest. Okay, he isn't here today, but one of John Bucock's cast in stone design concept is this. It must be a grade, some kind of grade. I can't remember, it's a weird number, 8.42 whatever, by 14 point don't know whatever. But you know what he wanted? All the columns going up right to the sunscreen at the top is steel, and they are circular. But guess what? The magic number is all these columns must be 200. Okay, that's weird. Why I say it's weird? Because there's one column supporting nothing but the screen at the top. But of course, it goes up 14 meters, must be 200. Then there's another poor 200 column, have to support the whole office box in the middle, everything. It also must be 200. So whether it carries a light load or heavy load, it must be 200. Okay, I don't want to comment on the architecture, but okay, if that's your wish, we help you realize your wish. So some of the columns are hollow steel, some are infilled with concrete, and some are thicker. But thank God we didn't have to have a column that was solid steel, 200. Though we did do that once, but not John Bucock, for John Ding. Okay, so John Ding, he's also not here today. We once did a house for him, not for him, but for a client called Kwan in Sierra Mas. Okay, this is another crazy one. The column goes up 12 meters, okay, and they're supporting the whole house. It's not just any old column. Okay, guess what? Maximum size of the column, 100 by 50. I kid you not, 100 millimeters by 50, right? Okay. We made it happen. That is solid steel. But what I'm very angry about, and I don't mind telling him, after we spend all our lives, not lives, our time doing all this and all that, he puts a rainwater downpipe next to it. And the rainwater downpipe is bigger than the column. Now everybody says that's the column.
All right. Thanks for that, Aya. Actually, I have a continuous question to that first question of mine. So if those are just the normal concrete, why not use like lightweight cementatious facade like GRC or GFRC as the wall panel or even as a finished formwork instead of using a wood plank as a finished formwork? Because precasted lightweight panel would be easier for you to do a QC before it's installed onto the wall. So I'm just wondering, from architectural point of view, why not the GRC?
I think it's not that the column don't do any work. It is still doing the structure, performance, and the support and all that. That facade wall, which interfacing between column, as in off-form concrete, and also the glass facade, the column, the concrete itself is still doing the support. So I think what's going on is that, you know, grade 35 or grade 50, the whole reason, like Pekka say, is to achieve the architect dream, to have the consistency of, you know, the same sizes. And even though, for example, she explained about the solid metal and all that, is all to achieve an intent. Yeah. An intent.
I mean, sorry, I mean using GFRC as a finished formwork, and then you could infill concrete inside. Would that be an option as well, or?
But if we are to do the off-form concrete building facade and to study the intent of raw material, I think we are not in that
direction to go down that route. And it doesn't fully gel with the entire intent that we are putting the concrete as a backdrop. We do have some GFRC in the project. Like for example, our staircase, the escape staircase, there are GFRC platform on them, and they are being used in a way that they are, you can precast them, easier to install. You can control the tolerance in between the cast in situ concrete with those steps. So they are used in a way that, for that purpose. But on the wall itself, we wanted the off-form finish, which, GFRC can try to match it. I don't think it's exactly similar. And then go back to the tie rods and all that. Although it is very technical, but we spend a lot of time with TANG team trying to figure out exactly how we want the arrangement to be. Yeah, so all that come parts of the characteristics of an off-form concrete. Yeah, what I remember was we have our preferred arrangement, and we came to, and when we engage with TANG team, there is the requirement of minimum spacing and all that. So as an architect, we were not fully aware of those when we're doing the intent. All what we think of is proportion. When you're standing there, where you want the tie, you don't want to see the hole directly. You want it to be separated properly in a panel, in a wall. How you want to flow the interior to exterior. So all that kind of intent was in the architect mind. But when we engage with contractor, there is another different conversation. So what is really important is really that state of time. It's not like rushing into a construction immediately. Yeah.
All right, thank you. Sorry.
I just wanted to debunk something. I think, if I didn't get it wrong, your question was really why did they not use GFRC as the formwork, and then you pour the concrete in? Is that your question? Yes. You can't. You can't. You see, when you pour concrete into a formwork, that Mr. Tang was talking very much about what Dr. Perry, he's talking about plywood. So let's clear everybody's mind. Plywood is just the panel to hold the concrete, on both sides. But my word is wrong. It cannot hold the concrete. It's just the surface. What gives strength to that plywood, right? You cannot just put tie rod and bolt two pieces of ply together. Cannot. You need those things called wailers. Those horizontal green. I think it was green color just now in your slide. Okay, blue or whatever the color was. You need those. So those wailers actually, you have a problem. You have to attach the GFRC to these wailers. And by the way, construction actually is not that clean. So by the time you're done with all this, your final surface of the GFRC will become very dirty and all that. And another thing is that GFRC is expensive. Wherever Mr. Tang is getting his plywood from, Russia, I heard, right? 100% your GFRC is even more expensive. So this is quite crazy in a way. That means the cost of it will be more. Your paneling will be more than the stuff we put inside. Okay.
Hi, my name is Michael. I want to address the question to Mr. Tang. Okay, for the work as specified, just as I mentioned, great care had to be given by the GDP Architect. Can you share with us about the costing? So much care and meta statement you need to do, roughly, just to enlighten us.
Don't know whether I cannot declare too much costing. I mean, basically, I can only touch on fair-face concrete. For fair-face concrete, the conventional concrete, the formwork cost is ranging between 45 to 60 ringgit per meter square. But for fair-face concrete, we are touching 100 ringgit per meter square. The reason is the formwork only. The plywood that we use, as I say, I import from overseas, which is costing 400-500 ringgit per meter square. So it's 600 ringgit per meter square, equivalent to 200 ringgit per meter square cast out, because it's divided by 3.2 meters square per piece of plywood. So the cost is going to be very expensive for fair-face concrete in terms of plywood. the concrete is special, makes special design, and the attention that you have to put to do fair face concrete is actually, you must be a passion. If you just want to collect money from the client and do a fair face building out, you will never achieve it if you don't have the passion. Okay, thank you.
Just now we have one more question. Yeah.
Thank you. My name is Nazlan, practicing architect. I actually have one question for Engineer Pek Hua. But before that, I'd like to congratulate Pam. He's quite an eye-opener on the technical know-how. But first of all, I think the fact that we managed to bring the whole team together, with the contractor, the engineer. For the structure engineer, I think after her performance today, I had question in my mind was, she surely should realize that she's in a room full of terrorist architects, So, so you're bound to get dreamers, among practical people, right? But that's the way of the architect. My question is simple, but first of all, I'd like to congratulate Pam. I think a round of applause to these guys, A lot of technical takeaways, And we realize the takeaway is the fact that close collaboration and a keen understanding of the technicalities is very, very important. And the projects that you have shared with us today proves that. I just wanted to ask, after all your rant and ravings on the problems and to get solutions for producing really good buildings, how do you sleep at nights?
How you what? Sorry.
How you sleep at nights?
How do you sleep?
Oh, okay, all right. Okay. Okay, I'm going to be a bit serious before we talk about how I sleep at night. Okay? Okay. All right, the first thing is this, okay? First and foremost, I'm not here to promote myself or the company from Web that I own. But you're right about one thing. You see, the starting point about all these great buildings, right? The key word is really a fantastic teamwork and collaboration between architects, MEP, they're not here, all these concrete supplies. I've worked with all these guys, they help me solve problems. They're very interested in problems, very curious. There's a missing person in this team, is the developer. The developer needs to be part of the solution also, very important. So as a team, as consultants, we need to also, in every project, bring the developer on board, right? But at the end of the day, there is something that I need to say, and it's not to make you guys happy. The architect will always lead, because you are the one with the dream. I think I'm a pretty creative person, but I was not born creative. I learned to be creative because I only have one engineer friend, and the rest of my friends are artists and sculptors and lawyers and architects. So along the way, you have taught me the beauty of beauty. And why I say that is because there are engineers and there are engineers. Why you know the names of great engineers like O.V. Arab, Cecil Belmont, Calatrava, Felix Candela, just a few, Felix Candela, is because first and foremost, engineers must want to have beauty in the product. Or else, all they want is, simply lah, give me some columns. I put some columns, building can stand up, bye-bye. Don't really care whether it looks like all kinds of chunky monkey here, there, everywhere, right? So that's why really good engineers, great engineers are rare. Because your brain works the other half. I always forget which half. My brain works the other half, okay? And somehow this great work only comes when an engineer thinks, with both sides of the brain. And how do I sleep at night? I love problems. And I cannot sleep if I don't have problems to solve. And I have the team, I'm not marketing, but I have a team with me who is, I think they only live when they have problems to solve, and very difficult problems. In fact, we want to solve problems that no one in the world has solved. That's why we don't know what name to give the company. I don't want to call it an engineering name, and because I don't even know, I only know how we start and what we are. I don't know where we will end up, because I have no idea at the end what kind of problems we want to solve. We know we want to solve any problem that is based on mathematics and science and rational thinking. We are not here to solve, like, human problems, like you quarrel with him and he quarrel with whom and all this kind of stuff. So give us your dream, right? And we'll rationalize it. Okay.
Maybe we have a last question. Anyone? Someone from upstairs? No? Yeah, we have one last question. Yeah.
I just want to ask this question as an architect. Maybe perhaps more towards the guy than the others. And following her question on the colored
concrete?
Yes. You get discoloration and patchiness and stuff like that with paint. Would you get that with off-form concrete, colored off-form concrete? Would you like to answer that? Or?
I think they just answered previously. Purple. Basically, it's just a pigment that we added into the concrete. Yeah, so you can achieve what sort of color that you want based on what pigment that they added in.
But be like paint?
No,
Would
pigment.
Would that be discoloration later on? No.
Will it
because
be
it's not a
discoloration?
coating. It's not a coating on the concrete.
No, it's not a coating. It's a pigment that added into the cement itself. Yeah.
There's a gentleman whose jacket matches his mask also mentioned the same thing just now.
Yeah. Okay. Tang have the question itself. To you all, maybe.
For Mr. Lim, YTL, my dream is we want to produce translucent concrete. So lights can go through.
No, actually, sorry, I don't mean to interject. Sorry, but we actually had that in 2015 in Milan. There was a pavilion, the Italian pavilion, that they actually had transparent concrete and the light actually glow. Yeah. So it has been done before. Sorry.
Yeah, thanks Mr. Tang for the challenges. I think I'm almost same like Ms. Pekha, that we love challenges, we love to solve problems. But for this instance, I think we can work it out. For adding the glass into our concrete to make it slightly transparent, I think CDL is capable. I think we are ready to explore this with Al-Ambia. No problem with that. Thanks.